Alright, now I'm going to cover a few problems from a previous year's final exam and just talk through my approach to solving these problems. So in this first problem, we're trying to solve the inequality, and basically we're asked to write in interval notation the set of numbers that makes this true. So the first thing that I note is that since I have on the right side of the inequality, I have this rational function, that I know that x cannot equal -4, because if it equals -4, then I have -4 plus -4, which gives me a 0 for my denominator, and since that's undetermined, that's not going to show up. So I have this spot in my number line where I don't have the -4. I keep an open circle, and I want to find some other critical points because that's going to be the easiest way for me to find out what's happening when one side is greater than the other. Okay. So for a moment, I'm going to pretend that these two things are equal, and I'm going to multiply the denominator, the x plus 4, on both sides. So then I have, once I distribute x squared plus 4x, and then I'm going to subtract 12 from both sides, so then I have the minus 12 equals 0. And then that's a nice quadratic that I can factor pretty easily, so I get x plus 6, and that's times the x minus 2. Because those are set equal to 0, I know that if x plus 6 is 0, then that would be 0 times something, so that would be 0. And I know that if x minus 2 is 0, then the whole thing becomes 0. And that's why this kind of reduction works. So to make x minus 6 0, x would have to be -6, and to make x plus 6 0. To make x minus 2 0, then x has to be 2. So I'm given some options. So I use that to create two more critical points. So those are the points, those x values are going to give me equaling 0. And you can put those in and see that if I put -6 and then 12 over -6 plus 4, that's 12 over -2. So that becomes -6, and then you see -6 equals -6. And so those are the places where they're equal to each other. All right, so I'm going to pick some numbers. So I picked -10, it's in this range. So what I'm saying is that everything within this range is doing the same thing. It's in the same category as any other piece. So when I pick out a -10, it's one of the whole range. And same thing here, I pick a -5, I'll pick 0, and I pick 8. These are not particular, though I might pick out numbers that make my calculations easier. So that's why I chose 8 instead of maybe like 3 or something like that. So then I can just plug those points back into my original and see what I get. So if I have a -10 here, -10, and I can go through that process of simplifying. So here I get -10 is greater than or equal to -2. That's not true. It's farther to the left on the number line. So that's not true. Here I find that this is true, not true, and true. So I find some areas where my inequality is true, so those are going to be the parts that I keep in. So when I like to kind of write over, so I'm including, since I have the equal 0 is inclusive, so I'm including this -6, and since this part was the part that was true, I'm going to have this all until I get to that -4. Then I don't have anything. I'm including my 2, and this goes on to infinity. So I have that open parentheses. And so I can just fill in the numbers and put my union. Okay. So hopefully that gives you an idea of how to work through this problem. Find some critical values, get some test points, figure out if they are true to the inequality or not, and if they are, then that section is entered into your interval of solutions. All right, let's move to the next problem. Here, hopefully, before you do this one, you look at one of the other videos from the textbook that explains the different logarithmic rules. So this one uses the multiplication and division rules. So I have a natural log here plus another natural log here. When I can combine those into one natural log where the terms are multiplied. And likewise, since I have this subtraction here, these can get divided. The one step that I did before that is I used the power rule that says if you have something multiplied to a log, that's the same as it being an exponent inside the log. So that's why you see the x squared here in the denominator, because it's subtracted. All right, and if I have a natural log of one thing set equal to the natural log of the other thing, then those inside pieces are the same. So I just distributed this through, simplified that. So I have this equation. Now I also noted that, remember we talked about earlier how logarithmic functions have a restricted domain. And so I can't put in a negative number or 0. So I need a positive number. So here I could have anything above -2. Here I could have anything above 0. And here I can have anything above 2. Well, that's the most restrictive, so that becomes my restriction. So I multiply by x squared on both sides. I get the x to the fourth minus 4x squared. I subtract by 45 on both sides, so minus 45 equals 0. And now this is kind of like functions a lot like a quadratic, because we have x squared squared, and then we have x squared. So we can factor it much like we would a quadratic. Just now I have an x squared term, so x squared minus 9, and x squared plus 5. And then note this is a difference of squares that can be factored a little more. So I have my x plus 3, x minus 3, and my x squared plus 5. So I get all of these zeros, but the only one that fits into my domain is the 3. So I only have one solution that's a real value within my acceptable domain. All right. So for this next one, we have this issue. We have a ball. A ball is shot vertically into the air from the top of a 30-foot tall building with an initial velocity of 48 feet per second. The height of the ball in feet, t seconds after being launched, can be modeled by the function h of t is equal to -16t squared plus the initial velocity times t plus the initial height. How long will it take for the ball to reach the maximum height, and what is the maximum height? So t is telling us time, that's the how long part, and h is telling us the height. Okay. So we're talking about a maximum, and we have a quadratic equation which leading coefficient is negative, so it's a parabola that's opening down, which means we're going to have a maximum at the vertex. So we're going to go through that process of solving to figure out what the vertex is. So I'm going to go through the process that we've done a lot in class of completing the square. So I'm going to factor out the -16, that's the leading coefficient. So I get -16 times the quantity t squared minus 3t. And then the 30 again is not something I need to deal with right now, so I leave it outside the parentheses. And then I cut this term in half and square it. That gives me the value to complete the square. And since that was multiplied by a negative 16, I'm going to have to do the same thing out here multiplied by a positive 16 to counteract what I just added. So I added a value, or you could say I subtracted a value since it's negative. So I have to add back that same amount. And then I put it into my squared form. And then this piece in here becomes my vertex t value. And then all of this that's constant on the end is my vertex h value. So we can see those pieces there. So then my maximum, the time to get up to the maximum height is 3/2 seconds or 1.5 seconds. And then I simplified this here. So 16 divided by 4 is 4. 4 times 9 is 36. Plus 30, we get 66 feet as the maximum height. All right. And one more. We got the population of a town grew from 5,000 people to 15,000 people in 10 years. Assuming that we have uninhibited exponential growth, that means we're keeping with our pattern of what's the expected population in an additional 2 years. And we're going to leave our answer in exact form. So I'm going to use this exponential growth style of y equals ab to the x. And I'm going to start putting in my pieces. I need to figure out what my growth rate is. So I know a few things. I know my initial value, that was my a value, 5,000. I know my output value was 15,000. And I know that it was 10 years. So the only thing left that I don't know is how fast I'm growing, what that rate is. So I'm going to solve for that. So when I divide 15,000 by 5,000, I get 3. And so then I just need to find the base. So that's going to be, I wrote it as 3 to the 1/10. You could write it as the 10th root of 3 to get b. And so now I can plug those bits back in and say, if I want to go another 2 years from where I was at 15,000, growing at this rate, which we found previously, then what is my y value? And I just simplified this power to power, you multiply, so 2/10 or 1/5, and we're leaving it in exact form. The 5th root of 3 is going to be some decimal if you want, so this is as exact as we can get it, and it's that number of people that we should be expecting 2 years after we're at 15,000. And that's it for this video.